is a major one. It might be the most important one on the AP test. It's right up there with confidence intervals. So we learned how to do a confidence interval, right? And then we did like 4 different. No, you didn't learn how to do a confidence interval. You did. And we learned like 4 different types, right? Well, we're going to learn a test, how to do a test, and then we're going to do those same 4 different types. So T, Z, 2T, 2Z. And the difference is in an interval, what did the question ask you to do every time? Estimate. So try to make some kind of guess. Give me a window about the population. I have this small piece of data. I want to estimate what is really happening in the big picture. A test will ask you a yes/no question. So it'll say like, is this significant? Is the most common phrasing, but it can be other things too. And so the very first thing you have to do now in every question is a test or data. Then it means the proportions. And then is there one set of data or 2? So that's kind of the questions we're going to ask. We hadn't done the tests yet. So we didn't have to ask it before, but now we do. So I want to give like an overview of kind of what's going to happen before I get into this note packet. So the way this works, so go to the back and we'll just like jot down some notes. You'll have what's called a null hypothesis. H sub 0, 0 means null. This is like our initial, our starting point. So as an example, I might say mu equals mean SAT score in Milan. And I'm going to some conference and I want Milan to look really good. And so I'm going to say, hey, at Milan we have an average SAT score of 1200. Which we don't. That's absurd. Average like 1000. Well, when I go there, this is HA. This is the alternative hypothesis. This is what someone else might try to say about my claim. So I'm going and I'm presenting to these people at the school, and I say my average SAT score is 1200, and someone says, "Bull. I think it's low. That's really high. I don't think you have that level of student. I don't know, whatever. They think I'm lying. So they say that I think the average is less than 1200. Now they could say 3 different ways. They could say, I think that you're better than that. I think that you're worse than that. Or I think that you're just different than that. Like, I don't know if it's higher or lower, but it isn't 1200. Like, that's another thing they could say. And then our job is to test that claim. So instead of giving a window of like what the actual SAT score is, we're going to say like, yes, it is 1200, or no, we think it's lower. But we can't really say yes. Okay, so here's our options. You either get, we talked about this with the truther thing a little bit, right? So this is where this comes in. Let's say they come to Milan and they randomly choose 30 students and they give them an SAT. And they take the average of those students' scores. And those average, this would be X bar, right? That average came out to 1199.5. This was my claim. Standing up there, hey, the average SAT score at Milan is 1200. Someone in the audience says, you're full of it. I'm going to come check. They take 30 students, they get 1199.5. They have 2 choices now. They can either call me a liar, or they can say, okay, you weren't lying. They can't call me a truther. That's that show we were talking about, right? What is it again?
Drake and Josh.
Drake and Josh.
I can show you.
If we have time after, I actually want to see it.
Bet, okay.
Okay. Sway.
Oh, God.
So, if the average was 1199.5, does this person have evidence to be like, yep, you were lying, because that's 1200, I told you. But remember my claim, I get some margin of error too. Like, I get a little bit of wiggle room. So, let's back up. If I did a confidence interval, and the confidence interval came out to this, and my claim was 1200, would you call me a liar? No, because 1200's in there, right? So I get like a little bit of wiggle room with it. It doesn't have to be 1200 on the nose. at your school is 800 to 950, then could you call me a liar? Yeah. Now 1200 is not an interval. We're really far away, and I'm obviously full of it. But this is important. I do get wiggle room. So would 1199.5 convince you that I was lying if I claimed 1200? You only got 30 data points. Is that enough for you to be like, he's obviously lying, I'm going to sue him, this is garbage? Or is it kind of like, reasonable? Seems reasonable, right? What if it was 1150? Now I'm a liar? What if it's 1100? Or what if it's 1150, but now I have a sample of like 200? Would that convince you more? So there's different ways that I could like convince you. And the idea is, if we are far enough away from the mean, then so here, let's do this. I know I'm rambling. This is like a huge concept I'm trying to start explaining, and it's not like gonna go perfectly, but we're gonna talk about it a lot. That's my claim. 1200. The standard deviation of the SAT is probably about 100. So we can kind of do this and set up our little things here. Now, if I got an 1195 average, I'm right there. That is very close to the mean. If I am very close to the mean, it's hard for me to say the mean is wrong. Let me repeat that because that's important. If my sample data comes out close to the claim, it's really hard for me to say the claim is wrong. You know what I'm saying? So I'm gonna stand up here. My IQ is 101. That's like completely average. I don't know why I would brag about that. I don't even know what it is, but I'm just saying. My IQ is 101. You're like, bull crap, you're an idiot. I think it's way lower than that. Alright, let's take an IQ test. I take one, comes out to 100. Would you be like, you were obviously lying?
Yes.
For 1 point? What if I got a 70? Would you say I was obviously lying? So the further that you are away from the mean, what does that make more likely? That I'm lying or the claim is wrong. So this, going back to the SAT, take a sample of 30, I take a sample of 30 and the average comes out to 950. X bar equals 950. I'm pretty darn far away from the mean now. And what can I say about my original claim? It's garbage. It's a lie. So when you are out in these tails, this is like the rejection zone. So if you're, and we're going to mathematically determine where that rejection zone starts and stops, and we'll have a way, so we're not like eyeballing it, like, oh, I think it's this. There'll be a way to say, but what I really want to hammer home is that the further you are away from the mean, the less likely it is that the mean is actually true. So as we get into the tails, here's the thing. If the sample came out to 950, what's more likely? I just happen to pick 30 kids that are way below the average, or I lied. Which is more likely? I lied. If you're that far away from, or I was wrong, I don't have to be a liar, I guess, but I claim my IQ is 101. I take one test, I get a 70. What's more likely? I just happen to have a really bad day, or I was lying. I was lying. And the further away I am from the mean, what does that make more likely? That I'm lying. Try it. I got a web page on the computer that I want to show you too. So this is what we were just talking about. So let's say 1200 SAT, that's my claim. What is that? Hold on. Oh, we're resolving host. Is the internet down? Do you guys have internet? SAT score at Milan is 1200. This person stands up and says, I think you're full of it. I think the actual mean is less than 1200. Standard deviation is about 100 on SAT. Can you guys see this? Okay. And I've only taken one test. Like, I got one test, and what I got was a 1050. That puts us, so here's 1200. 1050 is approximately here. This p-value is the size of this orange shaded region over here. You can think about this base, and this isn't perfect, but this is basically, so this 0.0668, the probability that they were telling the truth. So the lower this is, what does that make you think? They were lying. Usually the cutoff is 5%, so this is 6%, so the cutoff isn't quite there for me to say they're lying. But that's only like one test. I randomly picked one student, they got a 1050. Let's say I picked 10 students and their average was 1050. Well, now, like, the probability, I went too far, like, off the screen. Let's do 5 students. So here's the situation with this right here. There are 2 choices. Either I picked 5 students that just happened to be basically the dumbest 5 students in our school. Not that 1050 is a dumb score, but I'm just comparing it to that. Or this claim is incorrect. Which one's more likely? Incorrect claim. The further you go into the tail, the less likely that is to be true. Because you're getting such an unusual result. Like, is it possible that I would pick 5 students and they would get that average? Yeah. It's about that possible. So it's much more likely that the original claim is wrong. Does this make any sense? Are we getting somewhat of a... Okay. Yeah. Well, so the cutoff point like has a margin of error built in. You know, so if I said 1200 and the average came out to 1199, we wouldn't reject. Because that's like close enough. Like, you gotta be, the margin of error is basically the distance away from the mean that you have to be before you can be like, okay, now I've gone too far. Does that make sense?
So that's good.
If you're within the like margin of error, as you're calling it, then I wouldn't call them a lie. Okay. Another approach to the wild that is enormous. Now here's the liar truther thing. If I claim the average SAT score is 1200, and I do a confidence interval, easier to think about with confidence intervals. And I got this confidence interval. Remember, my claim was 1200, I got this confidence interval. Would I reject that claim? I wouldn't reject it because 1200 is in there. Did I prove it? Did I prove it actually is 1200? No. So I can't call you a truther. That's what that part is. Like, if this is what I resulted in, 1200 is in there. I can't call you a liar, but it didn't really confirm it either. It just means it's somewhere in this range. So this is the idea that you get your choices are reject, HO, or fail to reject. HO. You can never accept, so accept nothing. You don't get to accept HO. Alright, that's like an overview of the chapter. Let's get into this. We will talk about that a lot more. Hopefully an intro to like what we're trying to accomplish. But there's more. I mean, if you didn't pick it up there, there's definitely more chances. Okay, so null hypothesis. This is your HO. Again, null means 0. It's like a starting point. This is always about the population. And it's always equal. HO has to be something equals something. It might be mu, it might be p, it depends if we're working with means or proportions. But it's got to be, here's my claim, I think this equals this. HA, your alternative hypothesis, can be, well, I think it's bigger than what you said, I think it's smaller than what you said, or I don't know which direction, but I just think you're wrong. It could be like, it could be bigger or smaller. So this can either be greater than, less than, or not equal. We are trying to see if there's enough evidence to support this alternative hypothesis. There might be and there might not, and then that cutoff point is kind of how we determine it. So read through the this example for a sec. We used to call PAG integrated math way back in the day, and you can tell it's old because we used to think ACT. Now it's the SAT. But last year the average was 19.5. We tried some new techniques in integrated math. I want to know if the average score increased. Now, if it went to 19.51, is that a statistically significant increase? No. If it went to 27, is that a statistically significant increase? Yes. And somewhere in the middle there's like that cutoff point where I can say, okay, yes, significant, not significant, and that's what we're going to practice finding. So mu in this case, same way we did with the confidence intervals, I would say the true population mean ACT at mine. So you're defining a variable just like you would in a confidence interval. But then instead of saying like we want to ask, that first box on the template sheet, instead of saying we want to estimate at a 95% level, we're going to write these two things. So HO in this case would be, well, my claim is that my original starting point is that mu is 19.5. So this HO always has to have an equal sign. It's always this equals this. Always equals. And then HA would be, well, my goal is to improve the score, so I want to know if that happens. So I would say, okay, let's see if the mean is now bigger than 19.5. And then this is where we start playing that game. And we'll figure out the mathematical way to do it, but if my average comes out like right here, would that be enough to say like, yeah, that's significant? Probably not. But if I get into the tail and my new average is like 21.9 or something, again, the further away from the mean that I get, the less likely it is that the mean is true. Yes?
What's the symbol you use for not equal to? It's not equals 1.
What if there's another hand up? No? Okay, any questions right now? Try to write the next one. So you got to define your variable just like you did with intervals, and then instead of that intro sentence, it's these two equations. Or one's inequality, I suppose. So basically, most of the stuff we've been doing up this year leads up to this. This is like the culminating, I'd say the main point of the class. If you take a stats class in college, same thing. This is like the main theme in confidence intervals. All right, so I'd say mu equals true population mean Milan GPA. HO always has to be mu equals or P equals. In this case, it'd be mu equals 3. So that's the starting point. We want to see if that changed. And then this one didn't say I want to know if it's bigger, so I'm not going to put greater than. It didn't say I want to know if it's lower, so I'm not going to put less than. It said I want to know if it's different. So when it's different, you put not equal, and now I care about both directions. So let me explain what I mean by both directions. Go back to this one up here. If I claim 19.5, we want to know if integrated math increased the scores. If it came out to 18, would I think it increased the scores? Like if it went down, I'm trying to see if it went up and it went down, would I say it increased the scores? No. But if I'm looking at a different, now I can be like, okay, there is something going on. So it really depends on how you phrase the question. If I'm looking at just above, just below, or like either way. Yeah.
It says that the GPA for this year is already 2.8.
Okay.
What does that do? Because it already tells you that it's lower. Does that mean anything to us?
It means something when we go to do our math. So then we're going to figure out like what we'll use that for. Like it doesn't mean anything to us for just accomplishing this.
Okay.
What it means something for is So just in your opinion, does 2.8 far enough away from 3 that we'd be like, yeah, there's something going on there, or is that just kind of like, I don't know, GPAs fluctuate from year to year? And then we'll use that 2.8 with our process to see if it's past that cutoff point where we'd say, okay, it's not 3 anymore, or if it's close enough to 3 that we can be like, yeah, okay, that's reasonable.
But you wouldn't originally say that it's less than 3. You still just would say it's not equal.
So it's the question isn't is it less than 3? It's is it statistically significantly less than 3? Because you're gonna get like random change year to year in GPA just by chance, right? I mean, so this year might be 3, next year might be 2.9, next year might be 3.1, just because of the way things work. So in order for it to be statistically significantly less, it has to be beyond just normal fluctuation, and that's where we're at. Not just is it less than, is it like significantly less than, and we can actually say, okay, there's something going on here beyond just year to year fluctuation. I know 2.8 is less than 3.
No, yeah.
Okay. But the question is it like big time? Isn't it less than 3 enough that it's important enough that we can say, okay, yeah, three's wrong?
Oh.
Does that help?
I guess so.
It's a hard concept.
Yeah.
Yeah.
So this is like a question a supervisor would ask themselves to like see if they can change their response.
Absolutely. So that's a perfect way to, okay. So, yeah, so let's say Mr. Shin is judged on the school's GPA. It's not, but no, let's go back to this one. This one makes more sense. Let's say the school is judged on their ACT scores, because they were. Now it's SAT, but, and this is the scenario like the school board might look at. Like this was last year's average. All right, Mr. Shin, let's say this is like 5 years ago. All right, Mr. Shin, you're hired. Your job is to increase the ACT scores significantly, more than just year-to-year fluctuation. Because like every year the score is going to be slightly different, right? Those different kids. So it's it might be like 19.3, 19.5, 19.2, 19.8. If you get the score statistically significantly better, you get a $10,000 raise. So we would use this to see, okay, the score's going up to 19.51. Is that statistically significantly different, or is that probably just random variation? Probably just random variation. So we want to know, is it big enough past the point of random variation that he should get this $10,000 bonus? Yeah, that's a really good. Does that help some?
Yeah, I just don't know why you would say that it's just not equal to 3 instead of saying that it's less than 3 if they already tell us that it's less than 3.
Okay, it could be something like this. We want our grades, because there's like grade inflation, there's grade inflation here like crazy. Like, I think you guys probably know in your non-AP classes, whatever, doesn't matter. But say that principal's trying to prevent, he's like, our average should be a 3 every single year. Like that's how it should work. I want to know if it's different than 3. So different allows for, I understand your question. I can't explain it with your current knowledge level. Can I just say that at this point? We'll get to it. I just don't want to do it yet.
One more thing, you don't have to answer it if it'll just be the same thing. Are we not trying to find like it just for this year? Because you keep saying like it'll fluctuate year to year, but aren't we finding like just if the 2.8 is different from the 3, like for the 1 year?
Yes, but you have to allow for the fact that it's not just going to be 3, 3, 3, 3, 3.
Okay.
So there has to be some wiggle room before we're like, okay, this is past the point of wiggle room. Like, it's now far enough away that I can, you know what I mean? Is everybody a runner in here? I like to say Ben's better, right? Yeah. Ben, what's your mile time? Ben says his mile time is 5:23. But do you get 5:23 every time? Is that like your absolute best? What do you usually? Yeah. Okay. So Ben says my average mile is 5:30. But he's not gonna get 5:30 every time, right? That's almost impossible. So really, he's like maybe 5:15 to 5:45. That allows for normal variation. So it could be like it was rainy, it was cold, he didn't eat breakfast, he was up late studying for his test. I mean, whatever. But you're gonna have like some good and some bad, right? Anything beyond that. So look, okay, I got a supplement for Ben. I got it. I found it.
So a new pair of shoes.
Yes, I got a new pair of shoes for Ben. I'm like, hey, these are gonna make you run faster. Ben comes back and he's like, I ran a 5:29. Can I say the shoes made a difference? He's still well within that wiggle room, right? So I couldn't really say. So there's this normal variation that's just gonna happen. But now Ben comes back and he ran like a 5:01. Is that statistically significantly different? Yes. Because now we moved past just like the margin of error, like you were saying before, and we're at like a whole different level now. So this would look like, 5:30 is here, 5:15, 5:45, and I got something way over here. So this is like kind of like your margin of error. We're past that. And now I can say, okay, the shoes did something. Does that help?
So we're just finding at 2.8.
Basically. That's pretty good way to say it. 5:14. Well, I have to have a cutoff point somewhere, and I said 5:15 was my cutoff, so I would have been like, okay, that's different. Yeah. I don't have that pair of shoes for you. I'm sorry. I did find a supplement earlier. Try that.
What happened with that?
Conditions. We're gonna talk about the conditions now.
Oh, okay.
What are the conditions for a team test? You already know. What's the condition? What are the initials? Rit, right? What's R? What's I? Independence. There's two ways you can show independence. Mr. Smith, give me one.
You can assume that they are independent.
Assume each whatever is independent. Cooper, give me another one.
Your sample is less than 10% of your population.
So our small head is less than 10% of the population. You see one of those. This is not new, right? So this is hopefully review. And then T distribution, and you need one of three things there. Richard, give me one of the three. N is greater than or equal to 30. I'm going to put that second, because that's usually the second thing I check. What's the first thing I typically would want to check? Doesn't really matter the order, I guess. But so if the population's normal, we're good. If the population's not normal, we're good if we have more than 30. If the population's not normal and we don't have more than 30, we're still good as long as our small sample is what? Approximately. So that second box on your sheet, the exact same as the stuff we did before. And the math is easy. The concept I think is really hard to get people to understand what we were just talking about with all that. The math is not hard. Like I don't think that part's going to be an issue for you. But what I want you to do now, so I gave you, I believe, 5 or 6 concepts that are due Friday. You know how to do the first one. Hopefully after today, I want you to do the first one right now so we can see if there's any issues to go through now. You can go forward and try some other ones if you want, but we haven't learned them all. Just do the first concept. Oh yeah. Should I put it on the video that I'm uploading? I'll keep it on there. What? Yeah. This is it?
it plugged in? Like, is it all the way plugged in? It's like which?
Jeez.